Hello, my name is Damian Brady, and I'm an associate professor of marine science at the University of Maine. Today, I'm here to talk about New England Aquaventus's project off of the southern shore of Monhegan. I've been the environmental effects coordinator for the University of Maine's offshore wind program since 2010. So over that time and before that time, we've been deploying equipment to monitor the avian species, birds and bats, the pelagic species, so species that are swimming in the water column, and then species on the very bottom, on the sediment and ledge habitat that's below the wind turbine. So monitoring offshore wind installations is a pretty complex proposition because we have those three habitats to think about. And so most of our work on migratory birds as well as bats has been in three main areas: visual observations, so actual observers going out to the site and doing transects past the site to characterize the species that are out at the site. Then radar is the next big one. We actually deployed a radar off the southern coast of Monhegan to measure the target rate, the number of birds that were moving through the area, as well as the target height. So it counts the number of targets moving through the area. And then finally, we've also done some acoustic surveys of birds and bats that make noise on islands. So those are devices that measure bird calls and bat echolocation, and then characterize the bird and bat life around the island. While they're doing visual surveys, they're also looking for other protected species like marine mammals, for instance, as well as sea turtles or anything else that might be in the water during that time. As we go underneath the water, we put in passive acoustic monitoring equipment, or PAMs. These are essentially listening devices that can listen for instance, whale calls. So we're trying to characterize the whales that might potentially move through a site like this. Then we need to understand the pelagic, so the fish that swim through the area. We leave a receiver out at the area that measures the tagged fish, so fish that have been acoustically tagged by lots of other groups, including protected species like Atlantic and short-nosed sturgeon, as well as a lot of elasmobranchs or sharks that are tagged. If they've come through and they've been tagged, we have a receiving device that listens for those acoustic tags. And then there's a process called active hydroacoustics. That's when, if you've ever been on a boat and you've seen a fish finder, it's sending sound into the water and measuring the number of fish that essentially reflect that sound. So that's active hydroacoustics. So a survey that goes out and tries to characterize the fish that are in the pelagic zone. And then finally, on the bottom, we use something called remotely operated vehicles. So these are little mini robots that we send to the bottom, and they take video, and they have laser scales to measure the size of the fish, as well as the crustaceans that are on the bottom, like lobsters and crabs. We will repeat the ROV survey, the remotely operated vehicle survey, the hydroacoustics, as well as the visual observations and the passive acoustic monitoring when the turbine goes in. Most of the information that we're gathering is used directly in the environmental assessment for the program, and all the reports and information that we've collected so far. So the results of the radar monitoring, the visual observing, the remotely operated vehicle surveys, the passive acoustic monitoring are available at the Monhegan Energy Task Force website. And if you can't find something that you're looking for, please email and talk to me. I'm at Damian, DAMIAN.Brady@maine.edu. Feel free to reach out to me. Always happy to discuss the environmental and ecological results out at the site, and some of the upcoming monitoring that we have planned later on. Thank you very much.